Introduction to computer networks. We humans are not aware of everything by birth and need to learn. We ask our elders to understand things we don't know. We create social bond or network with our friends and family and seek information to accomplish some task we can't do by our own. Similarly, computers don't know everything by themselves and seek for the missing information or useful resource on other computers, network, and internet. Computers talk to each other over a wired or wireless connection using a network software, similar to humans using common languages. Computer is a general term used for device which can process information. It can be your laptop, a desktop, mobile, tablet, or even a smart TV. On the other hand, network devices are used to carry the computer message or signal to the distant computer we are trying to communicate with. Before we move further, a small request. If you like the way I explain, please say thanks by clicking the like button, share this with friends, leave a comment, and subscribe to get notified for future videos, as each minute you watch is an hour of love I put into these videos. Network applications. Just like humans learn or discuss various subjects and topics according to need, computers use different applications to gather relevant information over network. There are hundreds of services over internet. We will focus mainly on the commonly used services day to day. The first and most commonly used service over network is the World Wide Web. A web browser application is commonly used to access the service. The data is stored in a hypertext markup language or HTML format. The browser translates this info into a human understandable format. HTML pages are generally attached with a hyperlink on a web page to jump between pages. The next commonly used service over network or internet is exchanging emails. Just like old days where we used to write letters to each other delivered via post. With today's available infrastructure and speeds, emails are delivered in seconds, whereas physical post used to take days. Email is far more common and reliable method of communication compared to a letter post or phone call. Above are some commonly used applications for email exchange, either installed on your computer or accessed via web browser. The next application used over network is for file sharing. The file transfer protocol helps us send or receive files point to point. There are many other protocols like FTPS, SFTP, SMB, NFS, and many more. They all serve same purpose of transferring files from one host or server to other. Remote control. In today's world, people can work from anywhere in a hybrid environment and no need to be near to the systems they work on regularly. You simply need a secure network connection to your corporate over internet and a remote desktop application to access the remote machine console. You can control the remote machine's keyboard and mouse directly from your laptop or desktop, sitting at home or out somewhere. There are different types of remote desktop applications. Some need a software and some connect direct and provide different levels of security as required. Voice over IP. Our phones work on the service provider signal through a tower network. Distortion or bad audio is common in areas with bad network or no tower. But if you are lucky to get internet connection from a nearby Wi-Fi network, your mobile can switch to an internet digital audio instead of a tower radio network, provided your mobile phone and the service provider support VIP calls. Most service providers opt for it to reduce the need to increase towers. Most offices provide a desk phone to its employees to attend calls. Imagine getting a number for each desk from a telephone exchange. That is where an extension number comes in place, where corporate will have one number for all employees and an extension number for each employee. This may work till an employee have a permanent desk, but for roaming employees, the extension will be of no use due to the physical location. That is where the VIP phones come to rescue. Though they are in a network, the user need to log in on them to get the calls transferred to their extension. When a user is done working on the desk, they can simply log out from the VIP phone and log in on the next desk or location they are working on. Users can even have a software version of IP phone on their laptop or mobile phone to get the calls transferred over internet connection when not in office, enabling them to attend audio or video calls or meetings with ease over the existing network connection. Shared network storage. Shared storage is available as network attached storage, where a dedicated machine uses an app to bundle multiple disk drives to be used by multiple users, whereas the storage area network is a dedicated location for storing hundreds of disk drive clusters accessible over high-speed connection. The software and protocols used for SAN makes the storage look like a locally attached storage to a server in a different room. High availability. When you request something over network, the destination server need to process the information. The server response time depends on the kind of request and amount of data you requested, as it need to complete the logic to give the output. Each server is limited to the number of tasks it can process at a time, and if the job is huge, it will complete it in chunks. If the requests are coming from multiple users, they will be processed in the sequence they came in, where the users need to wait in queue for the data. Having more servers can reduce the wait time by redirecting users to next server. With the high availability network applications, as users will see it as a single server. Data processing comes in both small and big chunks. For example, a DNA sequence can take months to process by a single computer. If we can add multiple processors or multiple servers with a network application, the parallel processing will reduce the time drastically. Operation flow of computer networks. A simple network will be 3 or more machines connected to a central hub, where the signal from one machine is multiplexed to all other machines. Computers require a network interface card, wired or wireless, to connect to a network physically, which has a unique MAC ID or hardware address. Physical address can send only wave signals. The backend network chip converts the wave signals into zeros and ones. The network chip is controlled with a network software or driver, which needs a logical address known as IP address. There is a detailed video on these topics in the description. We will cover more on this in future videos too. Computer stores this IP address with name of the other computer in cache. IPs are hard to remember, hence we do DNS resolution of name to IP address. There is a link for a detailed video on DNS. Check the description to learn more on how DNS works. If you don't have a DNS server in your network, we can use the hosts file available under C drive, Windows, System32, drivers, etc folder on Windows operating system. We can edit the file with Notepad and add the IP address and the host or domain name of the destination machine as shown. When your computer is new on network, it sends a lot of broadcast requests to know about the other machines connected on the same network. These requests reach all machines connected on the same hub or switch, or even the adjacent interconnected hub or switch, causing a lot of noise in the network. With multiple machines on network, there are chances two machines decide to send a network request at the same time, causing a collision in the network. That is where a switch placed in a big network can reduce the collisions and limit it to a specific hub only. Modern networks don't use hubs anymore. Before proceeding further, there are some network concepts or terminologies you should understand and remember. Collision domain, where two computers send signal at the same time. Bandwidth defines how much data you can send or receive on a single cable, which is further shared by the number of machines connected on a site. Hub, a hardware device allowing one machine at a time to send network signal, multiplexing it to all other machines connected on the network. Repeater, similar to hub, but the main function is to amplify the signal from one cable to other to cover longer cable distance. Switch, smarter than hub and costlier too. Switch uses VLAN concept, which reduces the network collision, allowing multiple devices to communicate parallel. Switch maintains the destination MAC address table and sends the packet to the right port instead of forwarding it to every other port and reduce network noise. Bridge, similar to switch, it uses a software instead of hardware ASIC processor for MAC address filtering. It is slow and cheaper than a switch, but with the decrease in prices for switch, bridges are hardly used anymore. Types of network topology. Point-to-point. Simple network connecting two machines over a crossover cable. Star topology. Machines connecting to a centralized hub or switch, also known as hub and spoke topology. Ring topology. Hosts are connected sequentially in a daisy chain fashion. The last host in the ring is connected back to the first host, thereby closing the ring. Bus topology. Hosts are connected through a single cable, usually coaxial cable, with a terminator at each end of the network. Mesh topology. Every machine is connected directly with more than one network card or connector with other machine in the network. Let's end the session here for network introduction. We'll talk more about OSI model in the next video. So don't forget to like, share and subscribe and wait for my notification. Explore other similar videos in the meantime on the channel.